group. So I'll show you what it looks like. It looks something like that there. This is our little look. Good. So what are we asking today? Well, we're asking today, where do these groups fit into the scientific taxonomic classification? And this goes all the way back to Linnaeus, when Linnaeus was looking at how to classify organisms. And he asked some very interesting questions. So basically, the question was, wouldn't it make sense to put organisms that share similarities into the same group? And that's actually what classification is. It takes organisms and it puts those that share characteristics into the same group. But what it derives from is basically, it derives from the whole classification system, all taxonomy, that starts out with the kingdoms. And when kingdoms are described, that's the largest of all the possibilities. Everybody belongs to a kingdom. Then those groups that share similar characteristics are put into a phylum. So a phylum is a group of divisions underneath kingdom. The phylum then get subdivided into a class or classes. So they're separating organisms according to their similarities. The classes get divided into order or orders. Those get divided into family. They get a family name. And then you get down to the lowest classification. That would be genus, and finally species. So species is the lowest classification or separation among everything on the planet, is to be put into a species. And the species definition is the group of organisms with which reproduction is possible. The smallest group of organisms with which reproduction is possible. So you really can't reproduce outside of your species on a natural basis. Can you force it in a laboratory? Yeah. Are there some that are forced it in nature? Yeah, they become hybrids. But they're sterile. They can't have offspring from what their combined species are. So species becomes the lowest common denominator. And when Linnaeus was talking about binomial nomenclature, what he wanted us to do, and we still do it, is to use the last two divisions as the way we speak about us and every other living thing. Every other living thing is noted to have a genus, which is the supergroup, and then the various species that belong to that. So let's look at Staphylococcus. Staphylococcus is a genus name. It gets a little confusing because it also becomes a descriptor of arrangement. But it's a genus. So we have several genera that we're interested in that group. You know about Staphylococcus aureus. Aureus is the species. And when we write about it, because it's a proper name, we underline it or we place it in italics. It's always set aside. It would be like the first name and your last name. Your first name would be your species, your last name would be your genus. But we know that there are other genera in the Staphylococcus genus. So when you're reading about these organisms, you have to follow the scientific format, which is that if you're still speaking about the same genus in following words, you don't have to write out the whole genus, you can just use S. and then give the species. So S. albus stands for Staphylococcus albus. If we go to another genus, like Streptococcus, which again is a genus name, but it's also an arrangement. The Staphylococcus arrangement means a cluster of cocci. It's the clustering of the cocci that gets that arrangement name. And if it's a Streptococcus, it's a linear chain of cocci that are stuck together. So it gets a little bit confusing when we do that. There are other organisms that I'll name that we don't do that. But Streptococcus, one of the most difficult ones is Streptococcus pyogenes. Streptococcus pyogenes. That's the most dangerous strep that we know about. But we also have other strep. So if I'm talking about another strep, I can just use the S again, only now you'll know that it stands for Streptococcus, not Staphylococcus. This is a different species of the Streptococcus genus. So we're kind of covering a couple of things today. How you would do scientific writing, how you would interpret it, and what we really mean by the groupings of the organism. When we go to us, and this is on your paper, we are Homo sapiens. So for us, we have a genus name too. That means we've come all the way down in the divisions, and we can see that that is our name. So if you look at man, it's in really little letters on the bottom of that shoe. It didn't reproduce too well. We're in the phylum Animalia. We're in the class Chordata, in the kingdom Animalia. The phylum Chordata. The class, Vertebrata, then Mammalia, and then when that breaks down, the last two are the Homidii, which is what our genus is, and that makes us Homo sapiens. So for all the four things listed there, we can do the same thing. We can pick out the kingdom, we can pick out the phylum, the class, the order, the family, the genus, and the species. So column 1 is a reference of Streptococcus pyogenes, just to show you how that would work. Well, what does that mean for us to be able to put the rest of the animals or the rest of the organisms into kingdoms? And science is really a riot because they start out, somebody will come up with an idea, and then somebody else will fight about it and say, no, my idea is better. And so we see an evolution, if you will, of scientific information. In the beginning, they recognized two kingdoms. There was a plant kingdom and an animal kingdom. So if you look at the first column, it says the two-kingdom system. Plants, which is listed as plantae, included bacteria, cyanobacteria, chrysophytes, which are algae, green algae, brown algae, red algae, slime molds, true fungi, bryophytes, tracheophytes, and then the animal kingdom, the Animalia, which includes protozoans and multicellular animals, which is us. So in the beginning, there was a very clear division. And what they said to make this a division is that all the people in the plants had walls. They were surrounded by walls. That was the defining structure. And the animals, all the cells were surrounded by a membrane. Well, you can imagine that it was too simplistic. Nobody could do that alone. But in the beginning, we put all of the groups viruses we talked about into the plant kingdom if they had walls. And then, in the animal kingdom, those cells have cell membrane. What doesn't fit anywhere here is the viruses. So we can't get all 7 groups into some of these designations because the viruses just were so odd that they didn't fit anywhere. They had no cell structure.